Myself, Karanam Narayana, Assistant Professor, Vijayanagara College, Hosapete. Now in this session we shall understand an expression for velocity of longitudinal waves in fluids. Now, fluidity is the property of a substance to flow freely from one place to another, such as liquids and gases. Therefore, liquids and gases are called by common name called as fluids. Now let us understand. Consider a long cylindrical tube fitted with a piston at one end. When the piston is at rest, then all the fluid particles are also at rest. Then the initial pressure is Pi of density rho. Now here we are observing there is consider a long cylindrical tube which is being fitted with a piston at one end. Now whenever the piston is at rest, then all the fluid particles are also in the state of rest. When the fluid particles are in the state of rest, then the initial pressure is Pi and the density is rho. At any instant of time, when the piston moves towards right with certain velocity V dash, then it compresses the fluid right in front of it. If the piston moves in a time interval of t, then the distance moved by the piston is V dash into t. So whenever this piston moves inside, then it compresses the liquid here. And this compressed fluid will move with certain velocity, and this moves with a velocity equal to V dash. Then what is the distance travelled by this compressed fluid? This distance moved by the compressed fluid is given by V dash into t. Therefore, the distance moved by the piston is V dash into t. That means the distance is velocity into time. Then at the same time, the compressed fluid also moves with velocity V dash, but the front of the compressed region also moves with certain velocity. That velocity is V. These two velocities are such that this velocity V is slightly greater than V dash. That means whenever this piston moves inside, then the particles near the piston compresses. And this compressed region moves with velocity V dash. And beyond this particular region, the particles are in motion and they are in motion with certain velocity V. These two velocities are such that this velocity is slightly greater than V dash. Then what is the distance moved by the leading edge? The distance moved by the leading edge is V into t, that is velocity into time. Then what is the change in pressure? The change in pressure is Pi plus delta P. Delta P is change in pressure. Pi is initial pressure. Therefore, the total change in pressure is Pi plus delta P, which is the pressure in the compressed fluid. Then the piston must exert a force. Then what is this force? The force that can be observed like this. The pressure is equal to force by area. The force is equal to pressure into area. Therefore, the force exerted by the piston is given by Pi plus delta P into A. That is pressure into area. That is equal to force. Then the net force is given by the force on compressed fluid by the piston minus the force on the compressed fluid by the fluid in front. That is given by, the first component is given by Pi plus delta P into A, and the second component is given by Pi into A. On simplification, the term such as Pia cancels and we get this value as delta P into A. That is nothing but the net force. Then what is impulse? Impulse is defined as force into time, the net force into time. That is equal to delta P. Delta P is change in momentum. Change in momentum is mass into velocity. This velocity is nothing but change in velocity. This change in velocity is represented by V dash. Therefore, it is given by mass into velocity is v dash. Therefore, the impulse on the fluid is given by F net, the net force into time, that is equal to mv dash. Now, here net force is given by delta P into A, this component, that is the net force is delta P into A into time, that is equal to rho V into V dash, that is equal to rho V. V is volume. Volume is nothing but area into distance into V dash, that is equal to here rho into A. I take A outside, that is equal to L. L is distance. Distance is given by velocity into time into V dash. Now, this is the one term on the right hand side. This is the term on left hand side. Here, these two terms on equating A and T cancels. We get delta P is equal to rho V into V dash. This is the most significant expression. Therefore, delta P is equal to rho V into V dash. Then bulk modulus is defined as the change in pressure to the change in volume to the initial volume is defined as bulk modulus. Now we know that volume is nothing but displacement into area. Displacement is S into area. S is given by V dash into T into area. That is delta V is equal to V dash T into A. That is the change in volume is V dash T into A. And the initial volume is given by S into area, that is equal to Vt into A, that is equal to V into T into A. Now we replace these two terms here. Delta V by Vi is equal to, the first term is V dash Ta by Vt into A, that is equal to V dash by V. Therefore, delta V by V dash Vi is given by V dash by V. Now we shall replace this value here. The bulk modulus, change in pressure by change in volume to the initial volume. We replace this component by V dash by V. That is delta P by V dash by V. That is B is equal to, B is bulk modulus, that is equal to delta P, as we have proved earlier, that is given by rho V into V dash by V dash by V. That is equal to rho V into V dash into V by V dash. V dash cancels. That is equal to rho into V square. B is equal to rho V square, or V square is equal to B by rho, or V is equal to square root of B by rho. Therefore, the velocity of longitudinal wave is defined as square root of ratio of bulk modulus to the density is called as the velocity of the longitudinal waves. Hence, an expression for velocity of longitudinal waves. Thank you.